In recent months, the technology world has witnessed an event that many analysts are already calling the most important breakthrough in the computing industry since the emergence of artificial intelligence. Microsoft has unveiled Majorana 2, a next-generation system that could become the foundation for the first fully functional quantum supercomputer in history. And while only a few years ago most experts believed that true quantum machines were still decades away, today the forecasts are becoming increasingly bold. More and more scientists, engineers, and investment fund representatives are beginning to speak not in terms of decades, but in terms of just a few years. The reason for this dramatic shift in sentiment is not simply another scientific achievement. We are talking about a technology that has the potential to transform the entire digital civilization. That is why the unveiling of Majorana 2 generated such a significant reaction among the world's largest corporations, governments, military agencies, and investment funds. Many analysts compare what is happening to the arrival of the first microprocessors in the 1970s. At that time, very few people understood that small silicon chips would one day lead to smartphones, the internet, artificial intelligence, and a digital economy worth tens of trillions of dollars. Today, a similar situation is unfolding around quantum technologies. To understand the scale of what is happening, it is necessary to examine exactly what Microsoft has presented and why Majorana 2 has generated so much excitement. For many years, the main challenge facing quantum computers has been the instability of qubits. A qubit is the quantum equivalent of a conventional bit. However, while a classical bit can hold either a 0 or a 1, a qubit can exist in multiple states simultaneously due to the phenomenon of quantum superposition. This is what gives quantum systems their extraordinary computational power. But there is a serious problem. Qubits are extremely sensitive to their environment. Any heat, vibration, electromagnetic interference, or even the slightest fluctuations can destroy their quantum state. As a result, scientists must rely on highly complex cooling and error correction systems. In practice, much of today's quantum computing power is spent not on calculations, but on correcting its own errors. This is where the Majorana technology that Microsoft has been pursuing for nearly 20 years comes into play. Many considered this strategy far too risky. Some experts even argued that the company was heading down a dead-end path. While competitors such as Google, IBM, and others focused on increasing the number of conventional qubits, Microsoft invested billions of dollars in researching so-called topological states of matter. Put simply, Microsoft's engineers were attempting to create a fundamentally different type of qubit that would be far more resistant to errors from the outset. Such a qubit would not need to be constantly protected from collapse. It was intended to become a kind of armored quantum element, capable of preserving information much more reliably than existing solutions. For many years, this idea seemed almost science fiction. However, the company now claims that it has come closer to realizing this concept than ever before. Majorana 2 was created precisely for this purpose. In essence, it is not merely a new processor. It is a demonstration of an architecture that could potentially become the foundation of an entirely new generation of quantum systems. Immediately after the presentation, major financial publications began reporting that Microsoft had unexpectedly emerged as one of the leaders in the quantum race. Until recently, many analysts considered Google and IBM to be the frontrunners. Now, the situation has become far more interesting. If Microsoft's approach proves viable on an industrial scale, the company could gain a tremendous advantage over all of its competitors. It is especially important to understand that this is not merely a scientific competition. What is at stake is a market that could one day be worth trillions of dollars. The winner of the quantum race will gain more than just a new technology. They will gain control over the next-generation computing platform. Imagine the moment when humanity first created the steam engine. Then came power stations. Then came computers. Each of these milestones completely transformed the global economy. Today, a growing number of experts believe that the quantum supercomputer could become the next such milestone. The most fascinating part begins when we try to imagine the capabilities of these systems. Modern supercomputers are already capable of performing quadrillions of operations per second. They are used for climate modeling, drug development, aerospace calculations, and the creation of highly advanced artificial intelligence systems. Yet even the most powerful machines today encounter problems that are virtually impossible to solve within a reasonable amount of time. Some calculations would require millions of years even for the fastest supercomputers on Earth. This is where quantum technologies begin to look truly revolutionary. For certain classes of problems, a quantum computer is not simply faster. In some cases, the difference is so enormous that it becomes difficult to comprehend. A task that would require 1,000,000 years of computation on a classical system could theoretically be solved in hours or days on a sufficiently powerful quantum computer. This is why governments around the world view quantum technologies as a strategic resource of national importance. Military analysts have warned for years that the arrival of fully functional quantum supercomputers could fundamentally alter the balance of power between nations. A vast number of modern security systems are based on mathematical problems that are extraordinarily difficult for conventional computers to solve. Quantum machines could potentially accelerate such calculations dramatically. For this reason, the governments of the United States, China, European countries, and other technological powers are investing tens of billions of dollars into quantum programs. This is no longer only about science. It is a matter of economics, security, artificial intelligence, and geopolitical influence. That is why the unveiling of Majorana 2 attracted attention far beyond the technology sector. Many saw it as a possible indication that the long-awaited era of true quantum supercomputers may be much closer than experts believed just a few years ago. And if that is indeed the case, humanity may be standing on the threshold of the greatest computing revolution in its entire history. But if the emergence of a quantum supercomputer is already generating such intense debate among scientists today, even more controversy surrounds the question of what will happen to the artificial intelligence industry after the arrival of such machines. This is where the most fascinating part of the story begins. Over the past several years, the world has witnessed unprecedented growth in AI capabilities. Models are becoming smarter, faster, capable of processing enormous amounts of data, and able to perform increasingly complex tasks. However, virtually all major companies working in the field of artificial intelligence face the same problem. Creating the next generation of models requires ever greater computing power. Each new version of AI is more expensive than the previous one. Giant data centers, hundreds of thousands of graphics processors, enormous amounts of electricity, and multi-billion-dollar investments are required. In fact, humanity has now reached a point where further scaling of artificial intelligence is beginning to run into the physical limitations of existing computing systems. This is why many researchers are closely following the development of quantum technologies. If quantum computers can perform certain calculations, orders of magnitude faster than classical machines, this could open entirely new possibilities for AI training. Imagine a situation in which an AI model could analyze not billions of parameters, but trillions, or could evaluate millions of scenarios simultaneously, discovering solutions unavailable to today's systems. Some specialists believe that quantum computing could become the bridge that one day leads humanity to the creation of true artificial general intelligence. Of course, most serious scientists emphasize that a quantum computer and superintelligence are not the same thing. They are different technologies. However, if we imagine a future system possessing both the power of a quantum supercomputer and the architecture of advanced AI, the consequences could be enormous. In essence, we are talking about a machine capable of solving problems that seem impossible today. It could accelerate the development of new materials, create treatments for the most complex diseases, optimize transportation systems for entire nations, design new energy sources, and model processes that modern science is not yet capable of calculating. This is why some analysts call quantum computers the future accelerators of civilization. They will not replace scientists, engineers, or doctors, but they may dramatically increase the effectiveness of their work. The impact of quantum computing on medicine is discussed particularly often. Today, developing a new drug can take 10 or 15 years. A huge portion of that time is spent modeling chemical interactions between molecules. The problem is that molecular processes are inherently quantum in nature. classical computers are forced to rely on approximations and simplifications. A quantum computer could potentially model such interactions with much greater accuracy. Many researchers believe that medicine will be one of the first industries to experience the benefits of quantum computing. New antibiotics, cancer treatments, and therapies for rare diseases could all be developed much more rapidly. Equally significant consequences are expected in the energy sector. Imagine a material capable of transmitting electricity with virtually no losses at room temperature, or new types of batteries capable of storing tens of times more energy than today's technologies. Currently, discovering such materials requires an enormous number of experiments. A quantum supercomputer could dramatically accelerate this process. Many specialists believe that quantum computing could be the key that allows humanity to move closer to creating new generations of solar panels, ultra-efficient batteries, and even commercial fusion reactors. If even part of these predictions proves accurate, the consequences for the global economy could be comparable to those of the Industrial Revolution. This is why Microsoft is currently attracting special attention from the investment community. For many years, the corporation has remained one of the dominant players in the technology market, thanks to Windows, Office, Azure, and artificial intelligence. But if the company truly becomes one of the first creators of a fully functional quantum supercomputer, its influence could grow even further. Some analysts are already comparing the potential situation to what happened after the rise of cloud computing. At one time, many underestimated Azure, considering it a secondary business direction for Microsoft. However, years later, the cloud platform became one of the company's largest sources of revenue. If quantum computing becomes the next computing era, Microsoft could gain access to yet another massive market. Imagine quantum services delivered through the cloud. Research centers, pharmaceutical companies, universities, banks, and industrial corporations could access quantum computing resources through Microsoft's infrastructure. In practical terms, this means the company could find itself at the center of an entirely new technological ecosystem. This is why investors are closely monitoring every statement Microsoft makes regarding Majorana 2 and the future plans of its quantum program. However, alongside the opportunities come significant risks. The more powerful a technology becomes, the greater the possibility of its misuse. Many cybersecurity experts are already warning that quantum computers could become one of the most serious challenges facing the digital world. Today, a huge portion of the global economy functions because of encryption. Banking systems, government databases, internet communications, and e-commerce all depend on cryptographic algorithms. Encryption is what allows billions of people to use the internet safely. The emergence of a sufficiently powerful quantum computer could threaten many existing methods of protecting information. For this reason, governments around the world are already working actively on what is known as post-quantum cryptography. New algorithms are being developed that are intended to remain secure, even in the presence of future quantum machines. In effect, humanity is beginning to prepare for the quantum era before it officially arrives. This alone demonstrates how seriously world leaders view the prospect of such systems. But there is another risk that receives far less attention. Many experts fear that the quantum race could deepen technological inequality between countries. If a fully functional quantum supercomputer is available only to a handful of nations or corporations, they could gain an enormous advantage over the rest of the world. Imagine a situation in which one country can develop new materials faster than all its competitors, create superior artificial intelligence systems, and optimize industry and scientific research at an entirely different level. Such a gap could fundamentally alter the global balance of power. This is why quantum technologies are increasingly viewed not as ordinary scientific projects, but as strategic resources of the future. In some ways, the quantum race is beginning to resemble the space race of the 20th century. The difference is that the prize is no longer reaching the moon, but controlling humanity's next computing platform. Against this backdrop, it becomes clear why the presentation of Majorana 2 generated such a strong reaction. To the average person, it may look like just another technology announcement. However, for specialists, it is a signal that the world's largest corporations are gradually moving closer to a goal that until recently seemed almost unattainable. And if current rates of development continue, humanity may witness within the next few years the emergence of the first quantum systems capable of performing real-world practical tasks and demonstrating advantages beyond the reach of even the most powerful supercomputers of our time. It is at that point that it will become clear whether the world truly stands on the threshold of a new computing era or whether a long road still remains before a genuine quantum revolution arrives. Yet the most important question being discussed today, not only by Microsoft engineers, but also by the leaders of the world's largest technology corporations, is far broader. What will happen when the first true quantum supercomputer ceases to be a laboratory experiment and becomes a fully operational tool for solving real-world problems? Many analysts believe that this moment could become one of the most significant turning points in the history of modern civilization. To understand the scale of the potential changes, it is enough to look at the history of computing technology. When the first mechanical calculating machines appeared, they transformed accounting and engineering. When electronic computers emerged, the digital age began. When the internet arrived, communications, economics, and education were transformed. When modern neural networks appeared, a new revolution in artificial intelligence began. But each of these technologies developed gradually. Quantum computing is different because many specialists expect a much sharper leap in capabilities. This is why some research centers describe the potential arrival of a fully functional quantum supercomputer as an event comparable to a technological explosion. The impact of such systems on scientific discovery is currently one of the most actively discussed topics. Today, an enormous number of scientific challenges are limited by computational capabilities. Scientists know which questions need to be explored, but they cannot calculate the necessary models within a reasonable time frame. Sometimes a single complex simulation requires months of supercomputer time. Imagine a situation in which such calculations could be completed not in months, but in days or even hours. The pace of scientific progress could increase dramatically. This is why many experts believe that quantum computers will not simply be another technology, but an accelerator for almost every other technology. For example, the entire world is currently working on the development of new materials. These materials are essential for electric vehicles, satellites, aircraft, medical equipment, and computing hardware. However, the search for the ideal material often resembles testing millions of possibilities. Researchers evaluate thousands of combinations of atoms and molecules in the hope of discovering the desired properties. Quantum systems could potentially accelerate this process significantly. They may help model material structures at a fundamental level. This means that future batteries could become far more efficient than today's versions. Electric vehicles could travel much greater distances without recharging. Smartphones could operate for weeks without being plugged in. Energy infrastructure could become dramatically more efficient. Some specialists suggest that quantum computing could also accelerate the development of robotics. Today, the creation of truly autonomous robots is limited not only by software, but also by computational resources. The more complex the tasks a robot must solve in real time, the greater the computing power required. If artificial intelligence one day gains access to fundamentally new computational resources, it could accelerate the arrival of far more advanced robotic systems. Robots could better understand the world around them, make decisions more quickly, and interact with people more effectively. This is why quantum technologies attract so much interest from companies working in artificial intelligence. Microsoft is already actively developing cooperation between its quantum computing divisions and its AI initiatives. Many analysts believe that in the long term, the combination of quantum computing and artificial intelligence could become one of the most powerful technological partnerships in history. But alongside the optimism come serious concerns. Some researchers warn that humanity may encounter consequences for which it is not fully prepared. History shows that virtually every powerful technology brings not only benefits, but also new risks. One of the main questions becomes the control of such systems. If a quantum supercomputer becomes capable of solving problems beyond the reach of most organizations in the world, who will control its use? Governments, private corporations, international organizations. Today, there is no answer to this question. Some experts propose creating special international agreements even before the emergence of ultra-powerful quantum systems. They draw parallels with the regulation of nuclear technologies. Of course, a quantum computer is not a weapon in the traditional sense, but its impact on security and the global economy could become so significant that it may require a new level of international cooperation. Special attention is also being given to financial markets. Many investors are asking what will happen to Microsoft's stock if the company truly becomes the first to approach a commercially useful quantum supercomputer. The history of technology markets shows that investors often try to price in future breakthroughs in advance. This is why any news about quantum technologies regularly attracts Wall Street's attention. If Microsoft manages to demonstrate real advantages of its Majorana architecture and begins scaling the technology, market interest could increase significantly. This is why every new Microsoft statement about Majorana, every experiment in quantum laboratories, and every publication from research centers is now being closely monitored by governments, investors, corporations, and scientists around the world. Because more and more people are beginning to realize that this may be the moment when the foundation of a new computing era is being laid, one that will define the development of humanity for decades to come.